So there's a couple different methods of constructing root 3. I think the easiest one is to realise that to construct root 3, okay, that means that the hypotenuse squared, so 3, has to be equal to the other two sides squared. So the square root of 2 squared and 1 squared. Okay, or the square root of 1, but the square root of 1 is just 1. Okay, so that's what we want. Okay, so the side lengths to use the theorem of Pythagoras. Okay, so if I want 1 squared plus the square root of 2 squared to be equal to the square root of 3 squared, so I'm trying to get a hypotenuse of the square root of 3, these need to be the other lengths sides of the triangle. So that's going to give me a hypotenuse of square root 3. So that's what I'm going to be aiming for here. Okay, so I am looking for, and you can draw out this little sketch, and there's no need to rub it out afterwards, okay, is a triangle where we've got a right angle and the sides are length square root 2, 1, and then my final hypotenuse is square root 3. So we need a side that is square root 2 to do this. So because of that, we actually first need to do the construction of root 2 to be able to construct root 3. So this is my kind of crappy looking construction of root 2 here. This here was the actual construction of root 2 that we done. And I'm just going to be moving back to this to write out the steps as we go. So my step 1, just because I've left the construction of root 2 here, is use the theorem of Pythagoras to construct root 2 by drawing right angle triangle with a equals 1, b equals 1 as a squared plus b squared equals c squared. So 1 squared, so 1 squared plus 1 squared equals 2 squared. Okay, so now my step 2 is I'm essentially going to be doing exactly this. I'm going to be using the theorem of Pythagoras to construct root 3 by drawing a right angle triangle with a equals 1 and b equals square root 2 as a squared plus b squared equals c squared. So 1 squared plus square root 2 squared equals square root 3 squared. Okay, but I'm not gonna kind of squish it all together that much. I've only squished it all together here because if I'm constructing root 3, then I don't want to spend ages writing out the steps for root 2. Okay. I have constructed root 2. I am now moving on to constructing root 3. So from this line here for root 2, I want to construct a 90-degree angle. It doesn't matter if I construct it from this side or from this side, but I want to construct a 90-degree angle from an endpoint of root 2. So that is step 2. So it's very similar to step 1 originally when we were basing it off a 1 unit length. Okay, I'm going to be doing the exact same thing now, but basically using this as my base, okay, the square root 2. So I'm going to construct a 90-degree angle from endpoint of, and be careful not to call this line segment that has a length root 2, be careful not to call it a line, okay, because actually in theory a line continues on forever in both directions, whereas this has exact endpoints. So construct a 90-degree angle from endpoint of, and originally when we were constructing root 2 we just were able to say from endpoint. Now we've got more than one endpoint going on. So from endpoint of line segment with length root 2. So length 2 units. Okay, so root 2 units. Okay, so I have an endpoint here and I have an endpoint here. It's up to you which one you want to construct the right angle from, okay, but I'd go up this direction so that we're not overlapping that many lines. So I'm going to construct a right angle triangle. So I'm going to go over this line that I already have here a bit wider so that we can see it nice and clearly as our base. Okay, so go over it a bit darker in your pencil. And now I'm going to continue this on in either of the directions. I shouldn't have done it like that. Okay, so I'm going to continue this on in either of the directions so that I'm going to be able to construct a 90-degree angle. So watch the root 2 video first as to why I'm constructing a 90-degree angle like this. Okay, really it's just to show the examiner as much as possible. So I'm drawing my intersection lines here and here. And then I'm going to move the needle to both of those intersection points with a slightly wider compass. And I'm going to draw an arc from one side and likewise an arc from the other. So only not using the pencil, not touching the pencil between moving the compass from here and here. Okay, it shouldn't be touched once. Even drawing the arc, it shouldn't be touched. So that is my new intersection point. So between this point here and this intersection point, that there will be a right angle from that line. So get your ruler out, match it up, and draw a line from the end point through that new intersection point. Okay, so that is my right angle triangle, or my right angle. Okay, so I'm just going to draw in there that is a right angle. Oh no. Okay, everything's going. Try and get rid of that line, but I can't. So I'm just going to redo just one small point here. Okay, so that black line is going to make it messy for us, but anyway, we are going to draw a right angle symbol here. Okay, so we want to show the examiner that is a right angle. Okay, so now what we have, so I'm just going to draw it in this one as well. Okay, I've just constructed a 90-degree angle from the root 2 line, and I've drawn in that it is 90 degrees to show the examiner what I'm doing. Okay, so that means that this line segment here is root 2. I now need this to have a length of 1. So this isn't like 1 centimeters that I can just measure with my ruler. 1 unit was the original line drawn. So we were relying on the fact that was 1 unit, and up until here is 1 unit. So I need, when I'm drawing 1 unit from this vertex, it needs to be basically the exact same length as whatever the original line was. So I'm going to use my compass. Okay, so step 3, use compass to mark 1 unit from vertex. Okay, so get your compass. Okay, when you set the compass needle and the compass width to 1, again here, it is a lot nicer to show your construction is like where you're getting the length from. So it is a lot nicer to actually just drag that around and show the arc the full way. Yeah, so just do that. And then when you move your compass away, we know that this point here is 1 unit up. Okay, so I am going to write in that is 1 unit. Don't know why the compass keeps popping back up. That is 1 unit, and I have root 2 units there. So I'm going to connect. So I have now marked 1 unit up. Okay, I am going to connect the 1 unit up point to the root 2 end point. Okay, so connect intersection 4. connect intersection point. With other root 2 endpoint. Okay, and then step 5, or just next line, this line segment has a length root 3. Okay, so okay, and then we need to explain that. Okay, so it has length root 3 units by the theorem of Pythagoras. Okay, so by the theorem of Pythagoras, as it is a right angle triangle okay, I'm going to run out of space, right angled, so I'm just going to use triangle. Okay, I probably go on to the next line with a equals, but I'm going to run out of space. So with a equals square root 2, b equals 1. So such that, so a squared plus b squared is equal to c squared, such that, so we said a was going to be the root 2 one, so root 2 squared plus 1 squared is equal to square root 3 squared. Cutie. Okay, so I have explained it. Now I could explain the Pythagoras bit. Maybe if you wanted to go more in depth you could, but this is like, that is perfect. Okay, the main things here is you're using pencil. If you make a mistake, you're rubbing it out. You shouldn't be scribbling out construction lines. Okay, leave all the construction lines there that are correct. And make sure when you're drawing 90-degree angle lines that you just put in the little L there, or a little box in the corner, just to show that they are right angles. Okay, and in your final triangle, it is nice to just have the lengths in there. Leave all your construction lines. So I haven't finished this one yet. Okay, so I might get the pencil just a little bit darker. Like I'll just, you know, if I was going quite light, okay, my last construction line is going to be root 3. So actually I'll just use a wider width to mean a darker pencil. Okay, that is my final root 3 length. Okay, and I've shown my 90-degree angles, and I've explained to the examiner what I have actually done, and that's it. Okay, but really, like, all these construction lines, other than this line here and this line here, that there's no rubber on this one, which makes it really annoying, but they were mistakes. Okay, so I should have a rubber to rub these out. If you do manage to, like, I don't know, flinch and just put a big cross through the page, like, that needs to be rubbed out. Okay, but all these other construction lines should be left there. Even if you think they look messy, it's what you're getting marks for.